Hi, my name is Emily Bujega, and I'm in third year electrical engineering.
Hi, I'm Felix LeClair, currently in fourth year computer engineering in the innovation stream.
And hi, I am Alex McKinnon in fourth year computer engineering.
And this is our ELEC390 Capstone project. This project is about a Goose Deterrent system, and the idea was proposed by our amazing supervisor, Dr. Josh Marshall.
Our supervisor came up with this idea for this project during his struggles of attempting to coexist with Canada geese while using his private shared beach as well as golf courses and other public parks.
So the problem we're addressing is the effect of Canada geese on recreational areas, both during the day and during the night, where they can be aggressive, deposit large amounts of fecal matter, and consume large amounts of local vegetation. This affects both communal beaches and municipal parks, minimizing the amount of usable coastline for multiple purposes.
Existing solutions that have been explored by our supervisor, as well as others affected by this problem, include sound-making mechanisms, a flashing light buoy, and swan or predator decoys. These solutions have been proven ineffective, and in many observed cases, the geese become familiar and unfazed by buoys and decoys, and sound-making mechanisms tend to be too disruptive to the surrounding community.
From our supervisor and other users of spaces that are affected by Canada geese populations, the geese primarily make their nests and nest when they have access to an area at night. Thus, the scope of our project is to deter Canada geese from being in an area at night. The areas that we are focusing on for the sake of this capstone project will be a grassy area in Lake Ontario Park, as well as our supervisor's beach.
So our solution is to create a move-in robot that uses computer vision to identify Canada geese and then deploy a deterrent mechanism to discourage them from loitering in the area. This deterrent mechanism could include sound, a flapping display with servos, or other methods to be determined after further testing.
The robot would primarily operate during the night, interrupting the nesting and resting cycle of the geese. This provides us with a humane way of encouraging the animals to seek out another area within which to nest and create their habitat.
The system design of this project is illustrated by the flowchart in the middle of the poster. All sensory data for environment processing, including all sensors, normal and IR cameras, will be processed through the onboard Raspberry Pi. It will then decide on navigational decisions and will be passed to the Arduino.
This sensor data will be used to determine instructions for the robot's motors and movement, as well as the deterrent mechanisms. These instructions will be sent by the Pi to an Arduino via pulse width modulation signals over multiple pins. The Arduino will then use these instructions to control the motors and deterrent mechanisms and send a signal to the Pi when they have been completed. So our development plan for this project spans approximately 5 months. This will begin in early September, where we will be finalizing our schematics and initial designs, followed by a building period, and then a final testing period in December and January.
The impact of the project stretches to 3 areas. First of which is the environment, where it eliminates a major source of land degradation. Secondarily, to the social environment, where it increases access to recreational areas. And the third and final impact area is the economic impact, wherein our product would free up natural parks as tourist attractions and enable further land development for the municipality.
Regarding risk mitigation, due to our nighttime operations, the robot will require the usage of IR LEDs and the camera for computer vision, and amber hazard lights paired with reflective tape to ensure the visibility of the robot.
We have determined that our total budget comes to $450. However, $100 of this includes components that we already have acquired. Thus, we require $350, leaving a $50 contingency.
So our first question is going to be for Emily. And that question is, what does this mean for the geese? Won't this negatively impact their habitats by limiting its area?
So the areas we are focusing on are a private beach and a section of Lake Ontario Park, both of which are within a kilometer of a dedicated conservation area. Additionally, there is abundant Lake Ontario shoreline that the geese can relocate to just west of these areas in Cataraqui Bay. The deterrent mechanisms that we will use will be humane towards the geese and simply encourage them to nest and congregate somewhere not constantly in use by humans. So our next question is for Alex. How will you consider the variety of terrain your robot will traverse over? How do you ensure the robot's mobility?
The robot will primarily be operating on safe, flat terrain as defined by geofences, and it will limit its movements if it detects itself leaning over too much on an incline as measured by the onboard accelerometer. Additionally, to ensure the robot can determine its speed and acceleration for proper traction, the robot is outfitted with an ultrasonic sensor to help determine the terrain beneath it that is driving across. And our final question for Felix is, does the robot have an abort system in case a flock of geese attack it?
So in the case where the system would detect an attack by a flock of geese, so this would be detected through a combination of extreme vibration in the accelerometer, as well as our machine vision system predicting multiple geese in very close proximity, the robot would convert to defense mode, bringing down its center of gravity, stretching out its flapping paraphernalia, and rotating in place at maximum speed, acting as a sort of vortex of defense and deterrence. This is key in establishing dominance in the minds of the geese, eventually leading to a general avoidance of any similar technology. Projecting towards the future, this would mean that the market and the geese themselves would evolve to recognize this sort of device and flee it at all costs, simplifying how we would deploy the system. So finally, I've been Felix with
Alex.
And thanks so much for taking the time to go through our presentation. Stay healthy, stay safe, and take good care of yourselves. Thanks.